All right, all right, all right. Thanks for tuning in. So we're helping you on solving radicals. I already had a video done from last year, and then they changed the assignment on us. What? So here's the assignment we're doing this year. And so radicals involve doing taking the square root. So to undo the square roots, we use the power of 2. So if there's not a number there, then you would use 2. And so that's the square root. So to undo the 2, you would use the power 2. And that undoes the square root. And if you do it to one side, then you have to do it to the other side. So that undoes the power 2. So then you get x minus 4 is equal to 1 squared. And 1 squared is just 1. Nice. So then, to finish this problem, we just add 4 to the other side. So then you get x equals 5. Nailed it. And then you plug it back in to make sure it works. So we're going to plug a 5 in there. So 5 minus 4. And 5 minus 4 is just 1. And the square root of 1 is 1. So 1 equals 1, it works. So that's going to be our answer for number 1. Nice, nice. Now number 2 does look a little tricky, so we'll take a look at that. Nice. Number 3 looks pretty easy though. Number 2 again, we'll square both sides, because that's technically a 2. A square root is just a second root. So those cancel out. And then we're left with 4a is equal to 4 squared. And 4 squared is 16. And then we'll divide by 4, divide by 4. So then 16 divided by 4 is just 4. Nice. So that's what a equals. Then we plug it back into the original. Wherever we see an a, we're going to plug in a 4. So maybe we'll use a different color for that. Let's try using blue. Nice, nice. So then we're going to plug a 4 right there. So 5 times 4 times 4 is 16. And the square root of 16 is just 4, so 4 equals 4. Nailed it. So that does work. That's the answer 4. So then you're going to look for those in your Canvas options there. Well, it's moving all around like a ghost again. What's going on? So weird. Okay, there we go. So then we're going to try number 5. Here we go. And we're going to name drop Jenna. Thanks for having us do number 5. You're famous now. So number 5 has 2 square roots. And so since it has 2 square roots, that means that we're just going to keep 1 on each side. And then we're going to end up power 2ing both sides to get rid of each square root. Nice. So then we're left with 15 minus 2a is equal to, just drop the radical, 8 minus a. Nice. That same process for number 7 as well, actually, now that I'm looking at it. So now we want to solve for a, get a's by itself. So I see, let's see, so I see one here. Maybe I'll do that in yellow. So I see this one and this one that we want to combine together. Now, just trying to think a little bit ahead, we want to keep our a's positive if possible. Right now they're both negative, but think about which one I get to the other side will make it positive. So if I add, you see that? You see that? If I add the 2a to this side, then it goes away here, and then we have 2a minus an a would give us 1a. And it's positive, so that's nice. Try to keep them positive. Yep. So then we want to go ahead and get this 8 to the other side. And how we get the 8 to the other side is the opposite sign, so minus it over to this side. And 15 minus 8 is 7. So our answer is a is equal to 7. Nice. So then we'll plug that back in just to make sure it works. I'm going to erase that work I did there just so I could plug it in, make it easy on myself, since I like to use an eraser. So now I'm going to plug a 7 in for A there, and plug a 7 in there. So then 7 times 2 is 14, and 15 minus 14 is 1. So I get radical 1 is equal to 8 minus 7. 8 minus 7 is 1. So then we get 1 equals 1. It works. Because the square root of 1 is 1. Square root of 1 is 1. So that's the answer, A equals 7. Nice. There we go. And then, there's the pause button. There we go. Thanks. All right, we're back. There we go. Okay, so now we're looking at 13, 14, 15, 16. Those are similar problems. You all have to do kind of the same process there. So let's try maybe number 15. Okay, so number 15. So when you power 2 both sides, now be careful, be careful. So you have to do the whole right side, not just part of it, the whole thing. Not just a piece of you, the whole thing. So that's 68 minus 4r is equal to, so then r minus 2 all squared is going to be written as r minus 2 times r minus 2. And the reason why is because you don't want to just square the r and square the 2, because there's a middle term you'd be missing and get it wrong. So let's take a look there. So now we're going to FOIL that out or distribute it. So r times r is r squared. Negative 2 times negative 2 is a positive 4. But then don't forget the middle terms. So you have a negative. So this is the eyes of our little creature. There we go. And then this is the nose, which is negative 2 times r, which is negative 2r. And then the smiley face, the mouth, which is another negative 2 times r, or negative 2r. And that's what most people miss when they do these kind of problems. They forget to combine those together and multiply that out. So now we're going to bring down our 68 minus 4r. And bring down our r squared. Then we have negative 2r minus 2r is a negative 4r, right? Combine those together, negative 2r, negative 2r, negative 4r. Good. So then we want to get everything on the same side now. And that's kind of an extra step or rule. I'd put step number 5 in our notes probably. Step number 5 is to get everything on the same side and then factor it and get 2 answers. Because this squared right here is going to mean that there are 2 solutions. Okay, there we go. So then I'm going to pause for a second while you try and get everything on the same side. So minus this 68 over and add the 4r over. All right, did you get a chance to go ahead and combine those to the same side? So we're going to go ahead next. We're going to minus the 68 over here. So that's going to give us a negative 64. Then we're going to add a 4r, because basically we want to get everything over to the right, to the same side. Ooh, that's going to, interesting. That's going to cancel it out on this side, but it's also going to cancel it on this side. That's crazy. So all we're left with is r squared minus 64. Nice. So then we just want to factor that puppy. So r squared factors into r times r. And 64 factors into 8 times 8 is 64. Now, we've got to check the signs. So a positive times a positive is a positive, which is not going to work because that's a negative. So then, if that doesn't work, what about both negative Well, a negative times a negative is a positive, and that's negative. So that means one of them has to be negative, one of them has to be positive. And so that's going to work because if you think about our 4r, those canceled, they became a 0r. So 8 times r is 8r. Negative 8 times r is a negative 8r. And so 8r minus 8r is 0r. So that means that we factored it right. So, because that's when you combine those together, you get 0r. So we did factor those right. Good, good, good. Now we're just going to set them each equal to 0. And so we're going to minus 8 to the other side. So we get r equals negative 8. And then we're going to add 8 to the other side. So then we get r equals a positive 8. Now I have a sneaky suspicion that sometimes the negative answers don't work, so we'll take a look and see. Okay, let's see here. Ooh, uh-oh. So I'm pretty sure the positive 8 is going to work. Because positive 8, 8 minus 2 is 6. Then if you plug an 8 in here, that's 8 times 4 is 32. And 68 minus 32 is 36. And the square root of 36 is 6. So the positive 8 definitely works. Positive 8 definitely works. But I'm a little concerned about the negative 8. Let's take a look at that negative 8 there. So the problem is that when you plug a negative 8 in, you get a negative 10 on this side. Okay. And then when you plug a negative 8 in here, you get negative 8 times 4. Negative 8 times 4 is 32. So 68 plus 32, good, good, is 2, and the 8 is 10. Carry the 1. And 6, 7, 8, 9, 10. So that's another 10. So that's 100. And the square root of 100 is 10, but not negative. Bop, bop, bop. Yeah, so that actually didn't work. So we would say this one's extraneous. Extraneous. Or you'd say it's no solution. So that one doesn't work. So only r equals 8 works. So then what we're going to do real fast is we're going to go onto Canvas there real quick. And we just want to double check because now I'm worried because I had to change one really quick before anybody else did the assignment because we had a wrong answer. There is an extraneous problem on there. So this was, let's see, which number was this again?
15.
Number 15. Beautiful. So then we're going to check number 15 real quick because I want to make sure that it is positive 8s and that's it. Let me just double check here. We'll let you watch me do this so you can see this process of how we edit these and try to make sure they're right. So number 15 is indeed 8. Beautiful. Okay, good. We got that right. Nice. Okay, so that's how we do that one. So now we're going to jump and do one of these harder ones. You thought that was hard, which it is kind of tough. Number 15, 16. Number 13, 14, square both sides. Again, what's the process? We're going to write this down. So one would be, it's not going to let me unless I do that, and that, and that, and that, and that, and that, and that. Okay. So basically, power to both sides. That's like the first step, right? Then the second step is to FOIL. First outside, inside, last. FOIL. It won't let me do the dot, so I don't know why. Then number 3 is, so after you FOIL, then you want to get everything on the same side. Get everything on same side. And then step number 4 will be to factor it. These are some good steps. Good steps to write down. Number 1, power to both sides. Get rid of that radical. Number 2, FOIL it out. So for example, this one, you'd FOIL out the v plus 4 all squared. So you do v plus 4 times v plus 4. So then that's step 2, FOIL it. Then step number 3 is get everything on the same side. The correct term is distributive property, right? Distribute it. But we like FOIL, first outside, inside, last. Number 3 is get everything on the same side. And then number 4 is factor it. And then step 5 would be check your solution. Check it out. Check yourself before you wreck yourself. So check your solution by plugging it back in. So those are the steps you're going to do for number 13, 14, 15, 16. Nice. Okay, here we go. So then we're going to do, let's see here. So these are the harder ones. We're only going to do one of them and let you try the other. So I'm going to pause it and let you decide which one you want us to do. Good. Okay, so here we go. Okay, we are now back to do a beastly number 18. So 18, we'll leave 17 up there. Oh, it's going to look like that. How fun. Okay, so what you have to do with number 18 is you need to get at least one radical isolated. So since that's negative, we'll go ahead and positive it over. So we're going to add radical 1 to both sides. Let me see here. Okay, so we're going to go ahead and add it to both sides. So this becomes a 1 plus. I said be thin. There we go. Okay, so 1 plus 1 minus 9v. Nice, nice. There we go. So that goes away to the other side. So we're left with the square root of 4 minus 2v is equal to 1 plus radical 1 minus 9v. There we go. Nice. So then we're going to do, now that we have one of the radicals isolated, then now we can square both sides. So we're going to square both sides, but remember you have to square the whole shaboozy. Square the whole shaboozy, the whole thing, like that. So square the whole thing. So now this will be nice because the radical just goes away, so we're left with 4 minus 2v. But on the right side, so on the right side we have 2 of those. We have a 1 plus radical 1 minus 9v, and another 1 plus radical 1 minus 9v. Nice. And so we didn't want to just square them individually. We want to FOIL it because now you're going to have lots of things. So then we do 4 minus 2v is equal to, so now here we go. Time to FOIL it. So first, so 1 times 1 is 1. And we'll do the last. So that's going to be the eyeballs. Look, 1 blue and 1 red. Okay, so now we're going to do the square root times the square root. And the cool part about that is when you're timesing a square root times a square root, right? Square root times a square root. That basically means that you have 2 of them. And so they'll just cancel out. So we're just going to have the 1 minus 9v. And the that blue and red is so funny. Let me see if I can fix that. The smartboard's being a smart aleck. Smart aleck, smartboard. Stop being a smart aleck, you smartboard, smart aleck. There we go. Awesome. Okay. Alrighty, there we go on this harder problem. Okay, so then let's see here. So we did 1 squared is 1. And then we did radical 1 minus 9v times radical 1 minus 9v. Some people want to see this, so I will. So we're going to do, basically, we're doing radical 1 minus 9v times radical 1 minus 9v. And so radical times radical is, or there's 2 of them then, right? Which becomes, there's 2 of them. So we can write it as radical all squared. And when you do that, because there's two of them, then the radical and the 2 cancel out, leaving us with just the 1 minus 9v. Beautiful. So that's not too bad. Then where it gets tricky is now we have to do the nose and the mouth. So radical 1 minus 9v times 1. Good. So that's going to be a plus 1 times radical 1 minus 9v. Then you have the mouth, which is the outside terms, which is another 1 times radical 1 minus 9v. So we're going to do plus another 1 times radical 1 minus 9v. There's so many of them. This is crazy. So many of them. This is crazy. Okay, so now we bring down the 4. Minus 2v equals. Okay, so now we have this one. And I'm actually going to do some combining now. I have this one with this one, so that's going to be a 2. So bring that down. Why does the black keep doing that? Ugh. So annoying. There we go. Okay, so 1 plus 1 is 2. Good. Now I have, let's see here, the minus 9v. We could bring that next if we wanted to. Good. So those 2 are moved over there. Now we move that over there, and we move that over there. Okay. So then, now we have a 1 radical 1 minus 9v plus another 1 times radical 1 9v. And so that means we have 2. That means we have 2 radical 1 minus 9v's. Cool. Okay, so now we want to get everything to the other side that's not a radical. So we're going to go to minus 2 to this side, minus 2 to this side. So 4 minus 2 is 2. And then we're going to add 9v, add 9v. And so a 9v with a negative 2v is a 7v. Good, good. So those are gone. And now we have a 2 radical. Now we have a 2 radical 1 minus 9v. Yeah, this is so crazy. Okay, so now let's see here. This is going to get even crazier. This problem is going to get even crazier. So we do want to power 2 both sides to get rid of that radical. But before we do, we actually need to get rid of this 2. So we're going to divide this 2 to both this and this. We got to divide it completely to the other side on both those numbers. So 2 divided by 2 is a 1. And then 7 divided by 2 is just a 7/2. Evil. I feel like something was not nice on this problem. Let me double check. Right here?
Top one under when you did foil.
When we did foil,
Yeah, right there.
let me pause it for a second. Okay, so this one is evil because there's a fraction. Oh, I'm glad we're doing the video for this one, so you don't have to do this at home. Hope you're watching. Okay, so now we have radical 1 minus 9v. Nice. Now we're going to have to square both sides. And so when we square both sides to get rid of the radical, that's going to foil this one now. So now we're going to have a 1 plus 7/2 v times another 1 plus 7/2 v.
Where'd you get an X from?
There we go. 1 plus 7. It keeps drawing a line. I don't know why it keeps crossing out my 7. It's making the X. It's not me. It's probably just tired, this board. Okay, so now at least we got rid of all the radicals, finally. So now we're going to do 1 times 1 is 1. 7/2 times 7/2 is 7 times 7 is 49. 2 times 2 is 4. So I just multiplied 7/2 times 7/2. So that's the first and the last term. Then we're going to do 7/2, let's see here, 7/2 v times 1. So that's going to be a plus 7/2 v. Then we'll get another, so that's the 7/2 v times 1, and another 7/2 v times 1. So we got 2 of those 7/2 v's going on, equals 1 minus 9v. This will not be on the test, way too hard. Okay, so 7/2 plus 7/2 is,
I don't know.
well, they have the same denominator. So that's going to be 7/2 plus 7/2 is 14/2. So now we're going to do 1. Oh, don't forget, this is 49v squared. V times v is v squared. Good. Okay, so 7/2 plus 7/2 is 14/2 v. We still have our plus 1 there. Good. And then we still have our plus 49/4 v squared. Good. 49/4. I'm running out of room. Right? This problem's too long. Let me see if it'll let me get some more room here. Unlock it. Ugh. Okay. Okay, nice. Still have our 1 minus 9v. Okay, so now let's see here. So we want to get rid of all these halves and fourths. So what we're going to have to do is we're going to have to multiply everything by 4. Lucarini, I curse your name. This is the worst problem ever. So now we're going to times everything by 4, and that's going to get rid of the fourths. Here we go. So 4 times 1 is 4, plus 14 times 4 divided by 2. So 14 and 14 is 28. 28, is that 56? So what I'm doing now is I don't like the halves or the fourths, and so I'm multiplying everything by 4, and that'll get rid of it, get rid of the fractions. That'll get rid of the fractions. So we're going to go ahead and do 4 times 14, and then divided by 2. So that's going to give us, this will become a 28v. Then this 4 with this 4, when you multiply those will just cancel out, leaving us with the 49v squared. And then we multiply the 1 by 4, that'll become a 4, and the negative 9 times 4 is 36v. Okay, now we're almost done. Now we're just solving, that's right. So now we're going to go to minus 4 to this side. Ooh, that's going to get rid of our 4s, interesting. And then we'll add 36v to this side, add 36v to this side. 6 and 8 is 14, carry the 1, that's 64v. Plus 49v squared equals 0. There is a v squared. I'm going to rearrange those because we're used to having the squared term first. There we go. Definitely not going to be on the test or quiz. Too evil. Too dang evil. Okay, so then I do not see what they have in common. Just a 7, 8, nope. None of those are in common. All they have is a v in common. That's kind of lame. So now we're going to have a v. We're just going to pull out a v. All they have in common, this is called single factoring now. So we're going to divide a v out is what we're doing now. So when we pull that v out, we're just left with 49v plus 64, because our v's will cancel, equals 0. And now we just set this side equal to 0. And so this will be one of our solutions, v equals 0. And the other solution, we're going to go to minus 64 to both sides. Minus 64 to both sides. And then we do so we're left with 49v. I think I remember this answer in the homework. This is ridiculous. Divide by 49, divide by 49. So it will be v equals negative 64 49ths. And 0. And 0. Holy cow, that was redonkulous. That was ridiculous and redonkulous.
So you said v equals negative 64 over 49 and 0?
Okay, that was ridiculous. So we'll finish off with number 20 and lets you do these multiple choice ones at home. So you can plug in solutions. I don't know if you've tried that before. You could plug in 4 and see if it works. Plug in 8, see if it works. Multiple choice is always fun. Or you can show all your work and have a good time. Okay, so number 20, we'll do last one. So the sum, what does sum mean? The sum means to add, right? It means plus. So the sum of the real numbers x plus y, x plus y. So the sum of the two numbers x plus y is 11. Nice. There we go. And then x plus y equals 11. Their difference, what is difference? What's the symbol for difference? Subtraction. So their difference means x and y's difference. So x minus y is 5. So we have x plus y equals 11, x minus y equals 5. And so now, we either could do the addition method or substitution. Most people like substitution, so maybe we'll do substitution. So what I'm going to do is I'm going to solve for one of these equations and plug it into the other one. So I'm going to go ahead and just add y to the other side. So then we get x equals y plus 5. And then we're going to take wherever we see an x in this equation, we're going to substitute in the y plus 5 into there. So now, instead of x, we have y plus 5 plus y equals 11. And now we can just solve for y. So 1y plus another y plus y is 2y, plus 5 equals 11. So
we have to add 11 to 8.
Yep, so we're going to minus the, what is that, a 5? So we're going to minus 5 to the other side. So 11 minus 5 is 6. And then bring down the 2y. So 2y is equal to 6. And then we're just going to divide. Divide by 2, divide by 2. And 6 divided by 2 is 3. So now we know...
Oh, we minus 5. Oh.
Yeah, we minus 5. Yep.
Added. Oopsies.
That's okay. So then we're going to do y equals 3 as one of our answers. But now we actually have to go back to the original, which our original, just either of them. We'll choose the first one, which was x plus y equals 11. That was our first original. So now we're going to do substitution, and we're going to plug the 3 back in for y. So now we have x plus 3 equals 11, because we substituted a 3 wherever we saw a y. Substituted a 3 wherever we saw a y. So there's the 3 instead of the y. And now we just minus the 3 over. And so then we're going to go and do 11 minus 3. And so 11 minus 3 is 8. Yep. And then last but not least, now we know what x and y equal. Now it's going to tell us to do, what is the value of x times y? Whenever two letters are next to each other, whenever two letters are next to each other, it means to multiply. So we found out that y was 3, we found out that x was 8, and 8 times 3 is 24. So that's going to be J. Nice. So thanks for watching. Come see me if you need more help. Email me. Thanks for watching. Peace out. Thanks for watching.